Hey, it's John at Tinderbox Arts. So this video is really about the need to be cautious and methodical when testing electrical components. All right, so quick background. It'd been about 2 or maybe 3 weeks since I had ridden this bike. I'd just been very busy at work and haven't had time to ride. So a Sunday morning came and I thought, it's real early. Let me just go out for a quick ride, clear the cobwebs out of my head. And, I got the bike out, turned it on, and the fuel pump was running, so there was voltage for the fuel pump. But when I went to actually start it, I got that click of the starter. There just wasn't enough juice there to turn the bike over. So I had a battery problem. The question was why, but one thing I will mention right up front here, and it's probably my own fault, is I have a GPS here which I had left connected. Now I normally keep this on a smart charger when I'm not using it. And I just neglected to put that charger on there. So this GPS probably drained the battery over a period of, like 2 or 3 weeks. Now I do have an SAE pigtail, which is connected directly to the battery. And I normally use this for the smart charger. And you could use it for other things as well. And so what I did was, it was that Sunday morning early, so I just grabbed a charger that I had it's a 6 amp, kind of a start charge to it. Not much, but enough probably to get me going. So I connected that, and the charger said it couldn't connect to the battery. In other words, it didn't recognize that it was connected to the battery, even though I was connected to this. I thought, well, that's weird. So anyway, I didn't have time to mess with it. I grabbed my son, and he pushed me to the top of the driveway. I knew I had enough voltage to get the fuel pump going, and that was working. So I just, kept the switch on. He gave me a push, popped it in gear, and it started right up, and off I went. So I knew when I got back, though, I'd have to do some diagnosing. All right, so this is the actual pigtail that was connected before I took it off to the battery on this bike. And, when I got back, the first thing I did was check this. One thing I checked was to make sure that the connector in here, because you have a negative side and a positive side, and I want to make sure, that this connector hadn't come apart or just been damaged for some reason. I checked that. It looked all right. And then the next thing I checked, of course, was the fuse, because not all of these pigtails have a fuse, but many of them do. So there's just a little box right here that holds the fuse. And I pulled out the fuse and checked that, and I could see that it was not blown. The fuse was still connected. So, okay, it wasn't the fuse. Then I pulled the seat off and looked at the connections to the battery itself, the physical connections, and those were fine. And, okay, so what's wrong here? Then I realized I had to go back and start over again. So I needed to do this methodically. And even though this is the most simple circuit, I mean, it's just a small length of wire here with a fuse. There's nothing to this. But again, it shows how careful you need to be when you're diagnosing things. So I had to do some diagnosing with the meter here. I got my meter out, set it on the ohm scale, and I just wanted to see if there's continuity, in other words, a connection between one end of these wires and the other. So first thing I did was test the negative side, and all you got to do is put a lead on one end, and I put the lead on the other end, and you can see from that meter, I go to 0. Take it back off, I go to 1. So I know I have connectivity on the negative side. Now the positive side has this fuse in it. So all I did was take the lead and put it on the positive end of the connector right here. And then I need to test on various, get this out of the way, various sides of this. So I have the positive end right here. Then I'm going to test this first length, because I'm going into, let's see if I make sure I get that on camera. I'm going into this little box for the fuse, and if I put my lead there, I go to 0. So I know I have connectivity between this first area of connection and the first area of the fuse box. Then if I take my lead back out, now I'm going to test the fuse box on the other side going towards the battery. Sorry, this is in your way again. So I put a lead here on this side of the box, see? And then on this side, where it connects to the battery, I go to 0. So I've now tested everything as far as these cables is good. Now another step I could take, what could be, and I did take, was to make sure that there wasn't a bad, you can have a break in the wire inside the insulation, you don't see it. So with this connected, you can take, let me do it actually, you can take this, and I get 0, but now I can take the step of kind of bending the wire back and forth, and I don't want to see that 0 change. I don't want to see any variation at all. So I didn't. I tested all that. So all this tested out good. So what was the problem? So that goes back to the fuse. Now I tested the fuse, but you can test it more than one way. I looked at it visually and it was still connected, so there's no reason to think it was bad. But now I'm suspecting that the fuse itself could be an issue. So we can connect this two different ways in this particular style of fuse. Up on the top here, there are two little ports, if you want to call them that, where you can put your meter, or you can just take the fuse out and test them across here. And that's what I did. And if I get this in my hand here, you'll notice there's no connectivity now, right? The meter is on 1, so there's no connectivity. But if I squeeze this together, oh, look at that. I have connectivity. So I realized right away that there's a problem physically with this fuse. It isn't blown, there's nothing wrong with it as far as that, but there's a physical problem, I'm not exactly sure what, inside here, where depending on how these leads are squeezed together or not, you'll get connectivity or not. And what happens is you put this fuse into this holder right here, and it will spread apart those little legs, and you may or may not get connectivity. In fact, let's try it right now for the heck of it. I'll put my leads right here. Whoop. I need one more hand here, I think. So I got nothing. So the problem is, physically, there's something wrong with this fuse. And, this is the fuse that came with the SAE pigtail originally. So obviously it needs to be replaced. But it kind of begs the question, some of these items that we buy for accessories, whether it's a pigtail like this, or whether you're putting in accessory lights, different, accessories that we add to our bike often have these fuses in them. And they may be a cheap fuse and it's not very good quality and something we should be replacing anyway. Now, not surprisingly, when I opened this fuse up, I took the plastic off here, and there was a physical damage between the two pins. So you can actually separate the two pins. It was not blown. In other words, it wasn't a matter of too much current going through there and it blowing. It just was physically damaged. So this plastic was holding the two pins together for the most part, but when you moved it around, or if you pushed that into that receiver, the pins would spread slightly, and that was enough to break the electrical connection. But if you took the fuse out and just measured it with a meter, the pins were close enough together where they actually touched, and you would have an electrical connection. So it's just physical damage. Now, this Bonneville of mine is a 2010 model. And older bikes do tend to have fuse blocks like this rather than a CAN bus system or something like that. So again, presumably these fuses are better quality, but when you're trying to diagnose a problem, it's worth thinking about the fuse itself, even though it doesn't look blown, or even though it may test right in a certain circumstance. It's worth maybe taking the fuse out and, kind of manipulating the legs of the connectors there a little bit and making sure you get a good test so that the fuse isn't physically bad and you don't really realize it. All right, now with the SAE pigtail reconnected, I have a new fuse in there. And now we should be able to see battery voltage when I connect the leads to the end here. And sure enough, we get battery voltage. So that's all it was, just a bad fuse, not a blown fuse, but a bad fuse. So just something to keep in mind when you're doing Diagnostic procedures on electrical stuff like this, especially with fuses, you just have to really pay attention to the detail like that. And that can make all the difference between getting it right and getting it wrong.